Was this term shorter than the rest?
I think it's the same. 10 weeks. 10 weeks. Fall's usually, well, I think until next year, fall has always been 1 week longer. But I think that's changing next year. And the reason I think is because we had the Thanksgiving holidays mixed in there too. So they try to make up the day. But winter and spring are, I believe, the same. 10 weeks plus an exam week. Say that again, Alina? Maybe. It could just be because it's spring, we're getting ready to get the hell out. Of course, that would make it drag, you would think. It's because of the enlightening jokes we tell in here. Keeps things rolling a little more fluidly. Lindsay!
So next year, are we going to have 4 weeks Christmas vacation?
I don't know. That's a good question. I don't know how that's going to. I think that would be nice, wouldn't it? I think the idea is to make it sync up with OSU's schedule better.
Okay.
So whatever OSU does, we're going to do, which kind of makes sense. Actually, none of it makes sense. We should go to semesters, but that's not going to happen until I'm dead and gone. But whatever OSU does, we're going to do, which makes the most sense, I think. Because I think right now, in the fall, OSU finishes a week before we do.
Yeah.
I think, right?
Students basically don't get like.
So, right, we're gonna like make that be less annoying.
Horrendous.
Less annoying. What's that?
It's horrendous.
Horrendous. Well, hopefully, it'll be less horrendess. This won't be perfect, but less horrendous.
It's like
All right.
2 weeks of finals.
I know. I'm sorry. But at least they're spread out. I mean, the density is less.
So we can't change the semesters because I'm supposed to graduate. Can't screw that up.
Well, not till you're gone with the Jared clause.
Yeah, exactly.
Grandfather Jared
Wait
in.
till after next spring.
Wait till after next spring. Then you can change semesters all you want. Friends, let's look at these kids when they can start using calculators. Then we'll get into some different data. All right, so I'm going to go with Darla again. I think we should look at the data first to make a call on these students. So I'm going to go back to my stat plot menu, now that I've written mu1 minus mu2 on the board forever. And let's just change our data up there. Plot 1, just change frequency to L, looks like L4, I guess, right? It's still L1 for the X list. It's still L1 for the X list because we're still using those test scores. Damn, puberty's still from Tuesday. We're still using the scores in L1, but now make your frequency L4. Make your frequency L4. And then I think for plot 2, make it L1, L5. So now we've got the Core Plus and the Trad kids with the calculators. We're going to see how that shakes out. We'll see how that shakes out. Make sense?
No, I just graphed.
Oh, you graphed it. You're one step ahead of us, Mike. So no, all we're doing, same thing. We're doing the same thing, except we're just trying to see if now let them use calculators. And I'm assuming it was a controlled experiment, so the kids were equal-ish in all ways, except the fact that they either did or didn't use the machines. So, shall we? Zoom 9. Okay, there we go. There we go. Looks kind of like the last graph, except now it's backwards. Now the Core Plus kids appear to be doing better. Now the Core Plus kids look like they're a little bit better, huh? Here's your Core Plus, and here's your traditional kids. So again, the mins and the maxes are roughly equal, but I'm looking more at this box in the middle, if you will, 50% of the data. So you've got this shift to the right of the Core Plus versus the traditional kids. So I'm thinking we may have our next set of hypotheses here. Maybe the Core Plus kids do better with calculators. And if you look at the description, and you may have forgotten this already, it's okay. The description of Core Plus Math is to encourage the use of technology in learning mathematics, rather than trying to restrict it with the belief that everything has to be done by hand. Well, maybe it doesn't. Maybe you can use technology to aid and abet the process, and that's kind of what Core Plus is all about. So taking a calculator away from a Core Plus student might result in worse test scores. So let's test it with. Let's test it with calculators. Okay? The hypotheses are going to look identical except for the difference in the sign. The assumption is that they're the same. But now, based on what Michael said, is that mu1 is going to be bigger than mu2. Which is exactly the opposite claim that it was last time. Because now the box plots have switched. The box plots have switched. Go ahead, Zoe.
So then are we switching the sign again?
Well, we are. Because look at this. Forget this, Zoe. Let's put mu1 on the left-hand side.
That makes sense.
Yeah, it does. This is when we tested last time. That's when we're testing this time. All you got to do is make sure you know what mu1 is. Go ahead.
We're keeping that sign.
Well, yeah, we're running a second test now. So
I know,
this
but
yes.
like, we're not.
Oh, yeah. yeah, we're keeping this sign. We actually, if you will, kept, both of these were the same statement.
I know, it's the way you wrote it.
I know, sorry. Yeah. I wish there was a quick and easy way to rectify the whole inequality thing. But I discovered, I think what it is, it's never used in algebra classes. You hardly ever use inequality signs in algebra. Everything's equal. X equals 2. 5 equals 10 over 2. There's no greater thans and less thans, or at least very rare occurrences. Paris.
You know what I was taught a long time
Yes.
ago was the bigger one, it's like a mouth.
Oh God.
It's like
It's
eating.
the alligator. Oh, sweet Jesus. Did that make sense to you?
Yeah,
Good.
that makes sense.
I have tried to explain, I guess I explained it wrong. I've tried to explain to people and it drives people nuts. Like, what are you talking about, alligator?
I understand it, it's just when you write it one way and then put in parentheses another way, that's what confuses.
But that's what I would love to rectify because I've written the same thing. Instead of writing A equals B, I wrote B equals A. It's like instead of saying, Zoe, I hope you have a nice day. It's like, I hope you have a nice day, Zoe. It's the same statement, but just I've reversed the arguments. But that's the part I wish I knew how to fix. I don't know how to make that clearer.
Always put U1 on the left.
We could do that. That might be a way to do it. Always go in increasing order. Let's just do that from now on. I only wrote it that way because that's what you guys told me to write. That's all I'm saying. Somebody said traditional is, you guys did. You said traditional is doing better than Core Plus. Well,
We'll take the blame, we just don't like it.
I'm
Move on.
just saying. I do what I'm told. I've been married long enough to learn that. 13 years. You do what you're told. Please, Susie.
Actually, when our times change.
Well, from this test to this test, yes, because we're now, that's why I wanted to keep these the same. Because then we just swap the sign back and forth on who's doing better. Fair enough? Good. Let's test it. So everything's going to stay the same except we got to go L4 and L5.
Again, number 4, 2 sample, right? Yeah.
Yes. We're still testing the same kind of data, so it's still a t-test for sure. So L4 and L5 for sure. And then just switch the sign up, because now we'll say the Core Plus kids are doing better. Yep. And then we draw it again. There's your curve. There's your 0 in the middle of mu1 minus mu2. If there's going to be any area, it's going to be on the right-hand side, because we're trying to see that they're doing better. There's some area. Are they doing better than the traditional kids significantly? Yes, they are. The test, it appears so. It appears. And as Mary pointed out at the break, we could be wrong.
Oh,
We could be wrong.
oh no.
With what chance?
Right.
This is a 5% chance, because this could be a potential
Outlier.
type 1. Well, it could be It could be an outlier, which would indicate a type 1 error. It's a false positive, which would be done by an outlier. You're right, Jared. So yeah, we could be wrong. But I mean, we're 95% of the time we're not. So there's a better chance we're not wrong when we get a small p-value. Fair enough? Believable? Jeez. Do you want to? Oh, we should put this down for your notes too. The T score is about 2, right? Yeah, about 2. P is about 2 and 2% ish. Go ahead, Susie.
So, can we test the 4 kids with and without calculation?
Sure. Why don't we? I was actually going to ask that, and I think back. I'm like, they might not want to do this, but since you're bringing it up, why don't we test the best of each batch against each other? So clearly, with calculators, Core Plus kids do better. And without calculators, traditional kids do better. Why don't we see if there's a difference between those two groups? Does that make sense? So in other words, let's test these guys with these guys. How's that? Let's see. And the thing is, we can graph the box plots, but let's just make this a two-tailed test. Let's just make it two-tailed to see if there's a difference. How's that sound? Rather than drawing the box plots up to see, let's just throw a two-sample t-test together to see if there's a difference. And we can run a confidence interval if there is one and see what the minimum difference is. So let's go to test, same thing, whoops, wrong one. Same thing, except now test L3 and L4 down here. So we're testing traditional without calculators, who were the best of that group, and then we're testing Core Plus with, who are the best of that group. And we're trying to see if either of those two beat out the other. It's impossible to tell from the original two tests because you weren't comparing them head to head. You were comparing them with regards to somebody else. Kind of like an NBA bracket. They both beat their respective teams. How would they do it against each other? Ish, kind of. Other stuff involved there, like betting and things. Cool? And we're just two-tailed. Let's just make it two-tailed to see if there's a difference. Why not? Now, of course, if we drew the box plots first, we might get an indicator of who's doing better. But without box plots, this at least tells us there's a difference. All right, shall we? We're going to see area on both sides, if there is any area. And there's quite a bit of area. I'll be damned, look at that. There's quite a bit of area. So, it's negative. It's negative, which tells me who actually had higher averages. This is a bit of a tricky question because you have to remember how you entered your data. You're right, L4 actually had slightly higher averages because you're subtracting smaller minus bigger and getting negative. But, tell me about that negative.
It's not statistically significant.
It's not statistically significantly lower. So in other words, we can't say there's a difference between these two groups of students. So in other words, core plus with is performing the same as traditional without. Does that make sense? That's all we're seeing here. I mean, you wouldn't have to know that that negative means the traditional kids are actually, or excuse me, the core plus kids are doing slightly better because it isn't statistically significant, so there's no reason to check it. If you wanted to, this goes back to what Susie and Jared said a few weeks ago. There is a 2-samp T interval. There it is. Remember the T interval we ran back in the day for these guys? We ran a T interval back in the day. There's a 2-samp T interval, does the same thing for 2 samples. So you can go ahead and just grab that if you want. It's already set up for you because you just ran the test. Everything's ready to go. Fair enough? Then just run the interval. Here it comes. Here's a blast from the past. How can you tell? How can you tell that there is no statistically, and I know that that's vomit-inducing looking at all that stuff at the top there. I see at the bottom. How can you tell there is no statistically significant difference between core plus kids with and traditional without based on that confidence interval?
It's huge.
Well, it's huge, but more importantly, what's in it? Huge is one thing. Huge is a function of sample size, though. What's in the interval that negates any statistical significance? A very, very important number. Say it nice and loud.
Zero.
Zero. That wasn't very loud. Zero. Zero. Zero is in that interval, friends. And if zero is in a confidence interval, remember what the zero is standing for? It's standing for the difference between mu1 and mu2. When the difference is negative, that means mu2 was bigger than mu1. When the difference is positive, that means mu1 was bigger than mu2. And since 0 is in there, they could be equal, which means this confidence interval is, as somebody said here before, inconclusive. We can't tell who's doing better or worse, simply because, just pointing at the right thing? Yeah, ish. Because it could either be that mu1 is less than, mu1 is greater, or mu1 is equal to. There's no confident, if you will, indicator. There are the averages. There's your traditional kids, averaging about 37.5. There's your core plus kids, averaging about 38, almost 39 points. A 1.5 difference is not significant when your margin of error is as wide as it is up there by like a 10 or 5-point margin of error.
What does DF stand for?
Great question, Susie. Fantastic question. DF, do you remember what that stands for from 243? Say no, because you don't. Totally fine.
No.
Stands for degrees of freedom. Do you remember, because I know for this too, when we talked about the T interval the first time about Guinness, how Gossett came up with the T distribution to help him. The only variable on the T distribution is the sample size. And the sample size is defined to be 1 more than the degrees of freedom. Back in the day, that was the value used. Nowadays, they use a computation called Satterthwaite's formula. Hang on, let me find it for you. This is the actual computation that is used nowadays for that number. So if you look at it and drink enough Guinness, you begin to see parts of it that you're like, oh yeah, I know what that is. Like, that's the variance. That's the pooled variance that you'll see, or I shouldn't say the pooled variance, the additive variance. And if you care about this, look on the Richmond page. It's got a write-up about it. And then you've got these guys down here. I don't know who the hell Satterthwaite is or why this is used as much as it is. I can't find any research on it. So I don't know why it's used, but it is used universally. It's one of those 5 questions in stat that I don't have the answers to and I can't find the answers to. And statisticians avoid the answers when I ask them the questions. So, but that's what's being calculated. So these sample standard deviations and these sample sizes are being plugged into this, and the thing that gets vomited out is that right there. So you can see why we don't do this crap by hand. It's passionately ridiculous. Fair? Please, Karen.
I just want to make sure that I'm getting the appears and does not appear right.
When does something appear?
Well, I know when it's small, but I'm just going with a statement.
Oh,
It
good for
does-
you, good for you.
It does not appear that traditional kids without calculators score better than core kids with calculators.
And you could even, you could say better, because that's true too. We didn't test better or worse, we actually just tested difference.
Okay.
Right, but yeah, it does not appear that anybody's doing better than anybody else. Yeah. Go ahead, Susie.
If you run L2 and L4, that's interesting.
Oh, it does? So the worst of each, of both?
No, just the core kid, with and without calculators.
Just
L2
the
and
core
L4.
kids worth. Oh, L2 and L4. Well, let's see. Curiosity peaked now.
Yeah.
So you're running L2 and L4.
Yeah.
So this is core kids without and core kids with. And did you have a belief going in, or did you just test it two-tailed?
I thought I tested two-tailed,
Mhm.
just to see.
Tested it two-tailed? All right, let's do it. Oh, well, look at that. I can tell something significant right now, because if it wasn't significant, you would have seen area on the left side and on the right side. Look at that. Which means core kids are definitely doing better with than without. We probably had that in our minds when we ran the two individual tests, but this is just more proof of that same statement. Good. Does something similar happen with the traditional kids?
I didn't have them.
Yeah, you can run L3, L5 and see if the same thing comes up. Yeah, Lynn's. Ash, is over there.
When we're writing, because I didn't say in respect to traditional kids, I put it appears core plus kids are doing better.
That's totally fine. I'm not gonna knock you for grammar and things like that. The thing I'm looking for is, did you say it either appears or does not appear that something happened? That's the first thing. And did you get some of the context from it? So if you said it appears the core plus kids are doing better than the traditional kids, I'm happy with that.
Okay.
Anything else is just over and above and icing on the cake. But you got the context. It's clear. It's concise. I can understand it. Your neighbor that you're trimming the hedges with is going to understand if you tell them that, right? I got a small p-value. Maybe type 1 error with 5% error. He's not going to understand that. They're going to understand what you just told me.
Okay.
So that's what I'm looking for, friend. Cool? And we're going to keep these next few days we have a couple days left, a few days left. We're going to keep saying these things out loud. We keep saying these conclusions out loud until we get super, super comfortable with them. Cool? All right, good. Was there significance there, Susie?
No.
No significance there. Interesting, very interesting.
So now, because this one's a negative though, wouldn't it say that the core kids without calculators would do better?
No, the core kids without calculators are doing worse, because remember you did this minus this.
Okay.
And that's the problem with subtraction, is you have to keep the idea of the direction because it's not cumulative. Because if you did it the other way, it'd be positive. If you did instead of L2, L4, L4, L2, it would be positive 2.7, not same p-value, but positive 2.7 versus negative. So, and that's the trick. That's the trick, and it's not always obvious. I don't test you on that because it's not always obvious. But it's the kind of thing that once you do this more and more in your careers, it'll become second nature to you. Fair? All right. Let me turn this off.